Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 10.4, Problem 5. This is Section 10.4, Problem 5. It says solve for x in each of the exponential equations shown below, and there's 4 equations. Part A, the equation is 9 to the 2x power equals 27. There's some value of x that will make that true. So to solve an exponential equation is a 3-step process. Step 1 is make the base the same on both sides. So instead of 9 to the 2x, let me write that 9 as a 3 to the 2nd power to the 2x. It's still 9 to the 2x, but I've written the 9 a little differently. And the 27 is actually 3 to the 3rd power. And you can verify that 3 times 3 times 3 is 27. And now on the left side, that 3 to the 2nd to the 2x, what you have is a power to a power. And the rules for exponents say when you have a power to a power, you multiply the exponents. So this will be 3 to the 2 times 2x power. 2 times 2x is 4x. So I have 3 to the 4x equals 3 to the 3rd. So now I have the same base on both sides. That's the first part of the process. The next one is set the exponents equal to each other. So if 3 to some power equals 3 to some other power, the powers must be the same if the bases are the same and the 2 sides of the equation are the same. So it must be the case that 4x equals 3. The exponent from the left half of the equation must equal the exponent from the right half of the equation. And then the last part of it is solve for the unknown value, for the variable. So just divide out the 4. So x equals 3/4. That doesn't reduce, but that's the answer. So x equals 3/4 is the value that makes the original equation true. That's part A. So B is a different exponential equation. It says solve the exponential equation 4 to the 2x plus 1 power equals 32. So again, first make the base the same on both sides. Both sides can be written as 2 to some power. So instead of 4 to the 2x plus 1, let me change the 4 to the version 2 squared, or 2 to the 2nd, and it's still to the 2x plus 1. So I still really have a 4 to the 2x plus 1. I've just written the 4 in a different form. And equals, the 32 that's on the right side of the equation is actually 2 to the 5th. So 2 to the 5th is still 32. I've just changed the way it looks. And now on the left, again, what I have is a power to a power. And the rules for exponents say when you have a power to a power, you multiply the exponents. So on the left, 2 to the 2nd to the 2x plus 1, let me multiply the exponents, the 2 and the 2x plus 1. So 2 times 2x plus 1, you have to do 2 times 2x is 4x. And then 2 times 1 on the end is 2. So now the left side of my equation is written 2 to the 4x plus 2 power. And the right side of the equation can stay 2 to the 5th. So now I have the same base on both sides. And again, this is an equation. I have 2 to some power equals 2 to some power. They equal, so the powers must be the same. So now I can set the exponents equal to each other. 4x plus 2, the exponent from the left side of the equation, equals 5, the exponent from the right side of the equation. Now, I want to solve for x. So let me get rid of the 2 that's on the left side. So I can subtract 2 from both sides. So I'll have 4x equals positive 5 and negative 2 is 3. And now to solve for x, divide out the 4. And it comes out to 3/4, just like part A. So that's coincidental. The answer is not always 3/4. And then part C, solve the exponential equation 2 to the x power times 8 to the negative x power equals 4. So again, first, make the base the same on both sides. Both sides can be written as 2 to some power. So the 2 to the x, I'm not going to be able to do too much with that at this point. So let me leave it as 2 to the x times 8 to the negative x. Well, 8 can be written as 2 to the 3rd. So instead of 8 to the negative x, I have 2 to the 3rd to the negative x. And on the right side of the equal sign, I have a 4. That can be written as 2 to the 2nd. So now I've taken a step in the right direction. Everything's 2 to some power, but I just need 2 to a power on the left and 2 to a power on the right. Now on the left, I have a power to a power again. So let me do something with that. So the 2 to the x that's in front of it, I can just leave that there. And now I have 2 to the third to the negative x. Again, that's a power to a power. So the rules for exponents say when you have a power to a power, you can multiply the exponents. So 3 times negative x is negative 3x. And the value on the right was 2 to the second. It'll just stay 2 to the second for now. So on the left, I'm getting closer. I have 2 to some power times 2 to some power. And again, the rules for exponents, one of the rules say when you have the same base and you're multiplying, you can add the exponents. So I do have the same base. Both sides are 2 to, or both bases are 2 to some power. So I can add the powers now when I'm multiplying. So x plus negative 3x is negative 2x. So the whole left side of the equation boils down to 2 to the power negative 2x, and that equals 2 to the positive 2. So now both sides of my equation are 2 to some power. So now I can set the exponents equal to each other. From the left, I have the exponent negative 2x. From the right, I have the exponent 2. And now to solve for x, divide out the negative 2. X equals 2 divided by negative 2, which I can reduce to x equals negative 1. So that's the answer for part C. And then finally, part D looks like it's the toughest. I think it's really not. It says solve the exponential equation e to the 2x times e to the 3x equals e to the 8th raised to the 10th power. Seems awful. So first of all, what is the e? Is that another variable? So in class, one of the things we talk about is e is just that special number that in science shows up so often it gets its own symbol. Just like in geometry, pi shows up so often it gets its own symbol. So pi is 3.14, and it goes on and on. E is just something that shows up frequently. It's the number 2.718, and again, it goes on and on and on. It never ends. So it's just a number, so we can just leave it as e. So on the left side of my equation, e to the 2x times e to the 3x. Again, I'm multiplying two things that have the same base. By rules for exponents, I can add the exponents together. So that will be e to the 2x plus 3x, which is e to the 5x. And on the right side of the equation, e to the 8th power raised to the 10th power. I have a power to a power. So again, remember there's a rule for that. It says when you have a power to a power, you multiply the exponents. So e to the 8th power raised to the 10th power is really e to the 8 times 10, and 8 times 10 is 80. So I have e to the 5x equals e to the 80. So now the base is the same on both sides. So I can set the exponents equal to each other. I have 5x as the exponent from the left side of my equation is equal to 80, the exponent from the right side of the equation. Now just solve for x. Divide out the 5. So x equals 80 over 5. Now I happen to know that that reduces to 16. You might not recognize it, so just use your calculator. 80 divided by 5 equals, and the calculator will tell you it's 16. So x is 16 is the answer for part D.